Hello, friends. I'm Commander Atul Rohatgi once again with you in my series of discussions, IIE Delhi HVAC Talks. Today, we are going to talk about cooling tower. And the first thing first, what is the need of a cooling tower? This is what we are going to discuss today. So, let's start with it. Why do we need a cooling tower? When we do a lot of cooling in the rooms or from the equipment, or we take the heat from processes that we are trying to cool, process fluids that we are trying to cool, all that heat that we collect, that needs to be dissipated. Now, how do we dissipate it? We can either use an air cooled condenser, it is a possibility, or we could use a water cooled condenser. When we use a water cooled condenser, we could also take water from a sea, from lake or river, or draw it from underground, or take it from the municipal sources. Can we? What will happen in case if we take water from sea, lake, or draw it from underground sources and discharge it back into the sea or the lake or into the underground? We will change the ecological conditions. We will change the temperature of that localized portion of the sea or the lake or the river, and this will not be allowed, because then it will change the kind of biological growth, biological life that is present in that area, that will change, and this will not be allowed. If we take water from the municipal sources, on one hand, it will be very costly to take water, it will be very, very expensive. And second thing is, where will we discharge it? That water at a higher temperature, it will be difficult to discharge that also. And all that water is required to be discharged. If we have an air-cooled condenser, then that would need open space. Not only it would need an open space, it would also need a bigger floor area, a very large floor area where the air-cooled condensers will need to be kept. The condensing temperature that we will achieve using an air-cooled condenser will also be high. Typically, the condensing temperature is 11 degrees centigrade over and above the ambient dry bulb temperature. So in Delhi, in case if the ambient dry bulb temperature for design is 44 degrees centigrade, the condensing temperature is likely to be around 55 degrees centigrade. This is a very high temperature, and at such high temperature, as the temperature rises, as the condensing temperature rises, the coefficient of performance also gets reduced, and it would lead to higher energy consumption. It would also need longer refrigerant piping, because now the refrigerant piping has to be from underground wherever the compressor and condenser and chiller has been kept. From there, the piping has to go to the rooftop where the air cooled condensers have been kept, and this would need longer piping. Longer piping means more refrigerant charge and also more possibility of leakages. If we have a cooling tower, then the condensing temperature is approximately 3 to 4 degrees centigrade above the wet bulb temperature. Mind you, last time when we talked about air cooled condenser, we were talking about the dry bulb temperature, and here 11 degrees centigrade above the dry bulb temperature. And here the temperature will be around 3 to 4 degrees centigrade above the wet bulb temperature. Wet bulb temperature is much, much lower as compared to the dry bulb temperature. Condensing temperature in this case will be approximately 20 degrees centigrade or more lower as compared to that in the air cooled condenser. Let's see what it will be. Condensing temperature in water cooled condenser. The typical wet bulb temperature in Delhi will be around 26 degrees centigrade, and 4 degrees centigrade above that will be around 30 degrees centigrade. So the condensing temperature will be approximately at 30 degrees centigrade. Whereas when we have air cooled condenser, the condensing temperature is 55 degrees centigrade. These are approximate temperatures. However, this shows that at such a high temperature difference, at such a high condensing temperature with air cooled condenser, the COP, the coefficient of performance of the chiller plant, will be much lower. And in case when we use water cooled condenser, the coefficient of performance will be much higher, and therefore we will be saving energy there will be reduced energy consumption, and it will have lot of beneficial effect. Greater COP, lesser energy consumption. We also will have shorter refrigerant pipes because now the evaporator and the condenser and the compressor, they are all in the machinery compartment. What is going out is the condenser cooling pipe, which is going to the cooling tower. So the refrigerant charge that is needed, that is much smaller. The chances of leakages are also much lesser. Blow down water. The amount of blow down water is just about 5% of the once through system. So the water quantity that we need to discharge, I was talking about that it is difficult to discharge water at a higher temperature. This time the water quantity will be just about 5% of the total quantity as would have been needed in the previous condition. So it will be easier. It enhances the process output. So this is what I was talking about. Why do we need a cooling tower? In our next presentations, we will talk about more aspects of cooling tower. Thank you very much for watching the ISHRAE Institute of Excellence presentation. This was on cooling tower. We offer many courses in HVAC. We can be contacted on these numbers that are given below. You can join us for your journey to start a journey in the field of HVAC and art. And in case you are already working in this field, then you can come to us for upgrading, enhancement of your knowledge and skill. We are present on YouTube through which you are watching us, and we are also present on LinkedIn, Facebook. We have a website which is given there. So thank you very much once again. Bye bye.